Hello class, this is Mr. Wood. Today we're going to be taking a look at integrals, specifically indefinite integrals. So let's go ahead and get started. So as you may know, many operations in math have inverses, like how addition and subtraction are kind of inverses or opposites of one another, and same with multiplication and division. There's a similar thing that applies to derivatives as well, and that is an integral. So similarly to inverses, if we can differentiate a function to find its derivative, we can integrate that derivative to find the original function, or if we are integrating any old function, we can integrate it to find what's called its antiderivative. So what does integration look like? First and foremost, one of the most important things in an integral is this symbol right here. This is called the integrand, and we use that whenever we want to take an integral of something. So let's take a look at this derivative function, y prime equals 3x squared. If we want to take the integral of that, we're going to go ahead and throw the integrand on both sides in front of the y prime and the 3x squared, and we want to throw this dx after the y prime and after the 3x squared. And so what the dx is telling us is that we are integrating with respect to the variable x. This isn't too important in very beginning calculus. However, once you do get onto more advanced calculus, that is a little bit more important. So whenever we are taking an integral, we just want to make sure to throw that dx at the end. So whenever we want to take an integral, what we want to do is add 1 to the power of each term and divide by that new power. So what we have here is 3x squared, so we want to add 1 to that power, so 2 plus 1 is 3, right? And then we want to divide that by that power, so if we multiply by 1/3, we're still divided by 3, right? So if we want to simplify that down, well, 2 plus 1 for this power is, of course, 3, and then 1 over 3 times 3 is going to be 1, so that's going to end up being y equals x cubed. However, we do have to tack on this plus c at the very end of this integral. And the reason for that is because, well, when we take the derivative of any function that has a constant term that's not being multiplied by a variable, that constant term just disappears, right? So when we're taking an integral, since this is kind of the reverse of a derivative, we need to put in this plus c just in case there is a constant in that antiderivative. Whether or not that's going to be a 0 or a number, we need to have that plus c in there. And so until we can figure that out, we need to keep that there until we can replace it with a number or take it off if there is no constant. So just make sure you keep that in mind when you are doing these problems. They can cost you a point or two on a homework or on a test. So let's jump into an example here. We want to integrate the function f of x equals 5x to the 4th plus 3x squared plus 2x plus 7. So one of the very first things we might want to do, just in case, because this might trip us up a little bit, after we set up our integral like so, integral of f of x dx equals the integral of our function dx, and we want to make sure that the function is in parentheses, we might want to multiply this 7 here by x to the 0th power. Sometimes it's a little bit hard to see what to do with an integral if not everything has a variable tacked onto it. So since we have x to the 0th power, well, anything to the 0th power is just going to be 1, right? So 7 times 1 is 1, so we haven't really changed the function. So what we need to do is, for every term that we have here, add 1 to the power and divide by that new power. So drag this down just a little bit. Since we have 5x to the 4th, well, 4 plus 1 is 5, right? And then we want to divide by 5, so we can multiply by 1/5 out in front. So we have 1/5 times 5 times x to the 5th. Same thing right here with 3x squared. 2 plus 1 is going to be 3. Divide by 3, so 1/3 times 3 times x cubed. Moving on here, this is 2x to the 1st, correct? So we have 1 plus 1 is 2, divide by 2, so we have 1/2 times 2x squared. And then finally, right here, 7x to the 0, well, we have x to the 0th power plus 1 is going to be x to the 1st. Divide by 1, so of course 1 over 1 is just going to be 1, times 7x to the 1st power plus c. So we want to simplify this all down. Well, luckily, all of the original coefficients are being divided by, well, themselves. See, we have 5 times 1/5, 3 times 1/3, 2 times 1/2, and then, of course, 1 over 1, which is still 1. So our antiderivative here is capital F of x equals x to the 5th plus x to the 3rd plus x squared plus 7x plus c. So there are some important things to note here. Oftentimes when we take an integral of any function that's not a derivative, so it's not like f prime or y prime, if it's just like f of x, like in this problem, then we take the integral, we find the antiderivative of f of x. So that's why this is a capital F of x, because it's the antiderivative of little f of x. And then, of course, never forget the plus c. Like I said, that's an easy thing to remember, but another easy thing to forget. So make sure that you get those on your tests and homeworks, or else it might cost you a point or two. It's an easy point or two. So let's move on to a little bit more ugly of an example. Number 2, integrate this function f of x equals 5x cubed plus 2/3 x plus 17. So let's go ahead and throw that into our integral notation. So we have the integral of f of x dx equals the integral of 5x cubed plus 2/3 x plus 17 dx, and we want to make sure that that whole function is in parentheses so it doesn't just look like we're taking the integral of 17 or something like that. Just make it look all nice and pretty and correct. So what we want to do is add 1 to the power and divide by that new power once again, just like in the last problem. So x to the 3rd, well, we have 3 plus 1 for the power is going to be x to the 4th, and we want to divide by 4. So 1/4 times 5x to the 4th. Once again, we have x to the 1st in this term, so we have to add the power by 1, so we have 1 plus 1 is 2. Divide by that new power, so we have 1/2 times the 2/3 that was already there, x squared. And then similar to the last problem, we could put in x to the 0 right next to the 17 if we wanted to, but we know that we can add 1 to that power, so we have 0 plus 1. Divide by that new power, so 1 over 1 times 17 times x plus c. Plus c. Always remember the plus c. So we want to simplify this down just a little bit. 1/4 times 5 is 5/4. 1/2 times 2/3. Well, we have a 2 in the denominator here and a 2 in the numerator here, so these can cancel out, and we end up with 1/3 x squared. And of course 1 over 1 is 1 times 17 times x is just going to be 17x plus c. And again, we have capital F of x because it's the antiderivative of little f of x. And never ever forget that plus c. So one last little note here. Sine and cosine. So we know that when we take the derivatives of sine and cosine, it's kind of a cyclic group here. So if we begin with sine of x and take the derivative, we'll get cosine of x. If we take the derivative of cosine of x, we'll get negative sine of x. Take the derivative of negative sine of x and we'll get negative cosine of x. And if we take the derivative of negative cosine of x, we should get all the way back to positive sine of x. It's the same thing with integrals, except this time we're going backwards. So if we integrate sine of x, we are going to get negative cosine of x. Integrate negative cosine of x, we'll get negative sine of x. Integrate negative sine of x, we should get cosine of x. And if we integrate cosine of x, we should get sine of x. And you should always remember when you are integrating that you will get plus c. So don't forget those plus c's when integrating. Alright, so hopefully now we are a little bit more familiar with finding indefinite integrals. You should be familiar and understand them a little bit for next class period. We'll be working on them just a little bit more. So I hope you have a great day, and I will see you in class.